first to face the dragons. These Harvard researchers believe they have the key to ending genetic disease.
Hello Dragons, I'm Jordyn.
And I'm Shadman. We are here representing the Broad Institute seeking $10 million for 1% of our business, CRISPR Technologies.
We believe that we have created a biotechnology tool that will allow us to change the course of genetic disease forever.
In 2012, we discovered a natural bacterial defense system known as CRISPR that works by attacking and cutting incoming viruses. We realized that we could re-engineer the system to cut out any designated DNA sequence. By doing so, we could cut out unwanted DNA as well as replace it with desired sequences.
The market for our patented technology is immense. With so many genetic diseases being left uncured, our product will provide patients with no treatment the chance they never had. Genetic diseases are caused by mutations in the genes of our DNA, and with our technology, we are able to actually correct these mutations.
I'm having a hard time wrapping my head around this concept. What's the success rate of this CRISPR technology?
Currently, the CRISPR system has reached 90% efficacy. Studies have been done in both mice and human cells, but unfortunately in 20% of these cells there was unintended damage and mutations to the DNA, which we refer to as off-target effects.
So will you be using our money to research this problem?
Yes. In medicine, we always aim to get as close to 100% efficacy as possible. Obviously, we don't want to be cutting DNA in unwanted locations. Thus, we're seeking a way to control the CRISPR system.
And we believe we have our solution. Researchers have discovered anti-CRISPR proteins which are capable of inhibiting the CRISPR system. Right now, we're looking for the right one for clinical use, such that the CRISPR system and the anti-CRISPRs are compatible in a human system.
So how will this anti-CRISPR increase the efficacy of this technology?
So, once the CRISPR system does its job and it cuts the DNA in the intended region, the anti-CRISPR will come in and it will inhibit this function. This way, the CRISPR system can no longer cut DNA and we can avoid these off-target effects.
Has any of this been shown to work in practice?
While we don't have clinical evidence of CRISPR or anti-CRISPRs working in humans, there's a massive body of research into the field. Research has been done mimicking human systems, we just haven't moved on to clinical trials as of yet.
You know what? I'm intrigued, but then again, why should I invest in you? What makes you think you're worth $1 billion, especially when you have no sales?
We may not have sales, but we do have potential, and our technology will revolutionize medicine. We have the expertise to take this technology to the next level and bring it to market. We just need your funding to make this a reality.
That sounds like all sunshine and rainbows, but you're asking for $10 million for a technology that has no guarantee of working. For that reason, I'm out.
You know what, Kevin? I don't think you're actually interested in helping people if you're not interested in the idea of this research. Do you even know how prominent genetic diseases are?
Well, Dragons, with 1 in 10 individuals being diagnosed with a rare genetic disease in the US alone, it's important to recognize the impact that gene editing will have on the future of healthcare. It's only a matter of time before scientists discover a system that is both safe and efficient.
You know, I love this idea. It is a lot of money, but I think it is going to a good cause, so I'm in.
Thank you.
Thank you so much.